Hello friends, very good morning to all of you. Today we are going to learn about two new notions. The first one is irreducible element and the second one is a prime element in a commutative ring with unity 1. So let us define these two terms. Irreducible element and prime element. So suppose that P be an element in a ring R which is commutative with unity 1 and P is non-zero, non-unit, and if P can be expressed as the product of two elements of R, then P is said to be an irreducible element in R if either A is a unit or B is a unit in R. If an element is not irreducible, in that case we say that that element is irreducible. Now we go for the definition of prime element. Here too, an element P in a commutative ring with unity. Here too, P is non-zero, non-unit, and if P divides AB for some AB in R, then P is said to be a prime element in R if either P divides A or P divides B. We know the notion of prime element in general ring of integers, but in general for a commutative ring with unity it is defined as this, and now we are going to find some examples of irreducible elements and prime elements different from that in the ring of integers. So let us try to find all those. So we consider the commutative ring Z6 with unity class 1. So we list all the elements of this ring. Now we take class 2. So 2 can be written as class 2 times class 4 because it will give class 8, and 8 is when it is divisible by 6, then the remainder is 2. In that case it becomes class 2. So class 2 is a product of two elements, class 2 and class 4, but we see that neither 2 is a unit nor 4 is a unit because in Z6 the units are only class 1 and class 5, and remaining 3 elements are 0 divisors in Z6. So here 2 is not a unit, 4 is not a unit. So this implies that class 2 is not irreducible. So class 2 is here reducible. Class 2 is reducible in Z6. Now, suppose that class 2 divides class A dot class B. Here we are going to check whether class 2 is a prime element in Z6, not. So suppose that 2 divides AB for some class A class B in Z6. So this implies that class A class B will be class 2 times class K for some class K in Z6. This implies, by the definition of product of two classes, AB class, it is 2K class, and this implies AB minus 2K is divisible by 6, that is 6 divides this one. So we have AB minus 2K equal to 6 times some integer for some n in Z. Or you can write this one as AB equal to 2K plus 6n. Now we observe that 2K is an even integer, 6n is also an even integer, so their addition is also an even integer, so AB must be an even integer. So this implies AB is an even integer, so therefore 2 divides AB. Now 2 is a prime element, prime in Z. So by the definition of prime element in Z, either 2 divides A or 2 divides B. This implies class 2 divides class A or class 2 divides class B. So here class 2 is a prime element in Z6, whereas class 2 is not an irreducible element in Z6. Here we observe that Z6 is not an integral domain. In the next class, we will show that if R be an integral domain, in that case, every prime element in R will be an irreducible element. Now we take another example. So we consider the commutative ring with the unity as Z, this one, or sometimes we also write this as this one. So its elements will be of the form A plus B I root 5, where A, B are in Z. So this is a subset of set of all complex numbers. So we know that this one with plus and dot is a commutative ring with unity 1. So here 1 is 1 plus 0 I root 5. So we take the element 3 in Z, this. because 3 can be written as 3 plus 0 I root 5, and 3 and 0 are in Z. So 3 is an element in this. Now suppose that 3 is the product of two elements in this ring. So write 3 equal to a plus bi root 5 c plus di root 5. Now the right hand side are two elements which are complex numbers. 3 is purely real. Now we take the conjugate of both sides, so it will give 3 bar. This one, by the definition of conjugation of a complex number, its conjugate will be a minus bi root 5. Its conjugate will be c minus di root 5. So because 3 is purely real, so its conjugate will be itself 3. Now we multiply these two, so you'll get 3 is a 9, and product of these two will give a square plus 5b square. These two will give c square plus 5d square. Now this is 9 and these are two integers. So what are the possible values of these two integers so that their product will be 9? So this may be 3, this may be 3. This one may be 1, whereas this one should be 9, and this one should be 9, and this one is 1. Now we see that this integer cannot be 3, this also cannot be 3. So now we take the other possibilities. If this integer is 1, if a square plus 5b square is 1, then this is possible if and only if a is plus minus 1 and b is 0. If we consider this possibility, then c square plus 5d square is 1. This is possible if and only if c equal to plus minus 1 and d must be 0. So in these two cases we see that a plus b root 5 will be b is 0, is plus minus 1. So these are units in this ring. Or c plus d root 5 is plus minus 1, as c is plus minus 1 and d is 0. So these are units in this ring. So you see that if 3 is the product of these two elements in this ring, then either this is a unit or this is a unit in this. So this element 3 in this ring is an irreducible element. So conclusion is that 3 is an irreducible element in Z root minus 5 or Z I root 5. Now we check whether 3 is a prime element or not. So we write 3 divided 6, and 6 can be written as 1 plus I root 5 1 minus I root 5. These two elements are in Z I root 5. So this implies 3. Now suppose that 3 divides, if 3 divides 1 plus I root 5, then 1 plus I root 5 can be written as 3 times some element of this. So we suppose that element is a plus bi root 5. For some a plus bi root 5 in zi root 5. So from this we see that 1 plus I root 5 is 3a times 3bi root 5. So this one must be equal to 3a, 1 equal to 3a, and a is in z. So we see that this equation has no solution in z. So this is not possible. Similarly, if we take 3 divides as 1 minus I root 5, we can show that this is not possible by similar process. So the conclusion is that 3 neither divides 1 plus I root 5 nor 3 divides 1 minus I root 5. So 3 is not a prime element in this. Thank you.